right, let's move to the next slide. This is also a disclaimer that says that Ashford University does not own the rights or does not take responsibility for any outside links or websites attributed to this presentation. All right, let's go ahead and get started. All right, I am so excited to present to you Dr. Juliet Krummick. She's worked for Ashford University since 2011, and she's teaching graduate and undergraduate early childhood education courses. She currently lives in Central Florida with her family. She graduated from the University of Central Florida with her bachelor's and master's degree in early childhood education. Her doctoral degree is in education with a specialization in organizational leadership from North Central University. Her work experience includes working in a faith-based preschool, teaching public elementary students from K through 4th grade, including Inclusion Gifted and the ESOL program to adults in online setting. We are so excited to have Juliet. She presents for us almost every single year. So Juliet, thank you so much for being here. Dr. Krummick, take it away.
All right, thank you very much for coming, and welcome to Engineering for Preschoolers. I'm so glad that you're here with me today. I hope that you leave with a little excitement to get your own little engineer imagining and creating masterpieces. Let's get started. All right, what you're going to learn during our time today. Well, what is an engineer? How early can we start to teach engineering skills? What can children learn? How will children learn? How can we integrate engineering into our learning environment? Benefits and barriers, and our future. Along with each topic, research will be supported by an activity you can use in your own learning environment to support engineering. What is an engineer? All right, so we're going to check out a great little video. Here we go.
How do we get around from place to place without having to walk everywhere? How can we communicate with people who live far away? These were problems that people struggled with for a long time, until recently, before there were things like cars and phones and computers. And you know who solved those problems? Engineers. But do you know what an engineer is? The short answer is that an engineer is someone who wants to know how and why things work. Now, I want to know how and why things work, but does that make me an engineer? Not quite. Besides being naturally curious, an engineer is a person who designs and builds things, like machines or systems or structures that help solve a specific problem. There's more than just one type of engineer, too. But no matter what type of engineer someone is, they have to ask themselves 3 very important questions when they're working. Number 1, what is the problem that needs to be solved? And number 2, who has the problem that needs to be solved? And most importantly, number 3, why is this problem important to solve? Let's take a look at some examples. A really famous example of engineering is the Golden Gate Bridge in San Francisco, California. I mentioned that there are different kinds of engineers, and a civil engineer is someone who designs and constructs buildings, roads, and yep, bridges. For the person who designed the Golden Gate Bridge, what was the problem that they needed to solve? People couldn't travel in or out of San Francisco, which is surrounded on most sides by water, without a boat. Who had the problem? Residents of San Francisco mostly, but really anybody traveling in the area. And why was the problem important to solve? Well, you didn't want a whole bunch of San Francisco residents trapped in San Francisco forever, even if it is a super cool city. Plus, you wanted people outside of San Francisco to be able to travel to the city easily if they needed to. So the Golden Gate Bridge was engineered as a solution to this problem. In addition to civil engineers, there are also mechanical, electrical, chemical, computer, nuclear, and software engineers, and the list goes on. Let's talk about what some of the other types of engineers do. First up, electrical engineers. Electrical engineers study electricity. They design electrical systems like circuits and computer chips. Think of an electrical object that you use pretty regularly. How about your microwave? What problem was the microwave a solution to? Cold food, right? You have an electrical engineer to thank for the ability to reheat that leftover pizza you just had for lunch. But while you might not have heard of Joseph Strauss or Percy Spencer, the engineers responsible for the Golden Gate Bridge and the microwave respectively, you've probably heard of Henry Ford. As in Ford cars? Henry Ford was a mechanical engineer, or someone working in the manufacturing industry, making mechanical things like tools, engines, and machines. Machines like cars. Ford didn't invent the automobile, but his Ford Motor Company made a lot of them. His Model T car was famous for being affordable for plenty of Americans. Ford saw that lots of people who wanted to drive cars just couldn't, because they couldn't afford the pricey vehicles that were for sale. So he engineered a cheaper model as a solution to this problem. His fellow engineers started to do the same, and now, well, cars are everywhere. Henry Ford's not the only big-name engineer. A famous engineer around today is Marissa Mayer. Mayer is the president of the internet company Yahoo, and is also a software engineer. Software engineers work on computers and other products that use software to write programs to make them faster and able to do more things. No matter what kind of engineer someone is, their job at its most basic level is problem solving. Each engineer just specializes in solving certain kinds of problems. While it might seem like there are too many types of engineers to keep track of, just wait 15 years, or 50, or 100, because we'll probably have a ton of different types to add to the list by then. Think about it. Over 100 years ago, we didn't have jobs in fields like aerospace engineering, where people design and construct planes and spacecraft. We didn't have planes like we do today, or need spaceships, so we didn't need people to engineer them. Who knows what machines or tools or everyday objects we'll have in the year 3015. Personally, I'm hoping for underwater cities. But whatever these things are, we'll need engineers to make them. So what do you say? Who wants to be an engineer?
All right. Now that we know a little bit more about engineering, let's get back to where we were. All right, so we're going to take a look at 3 of the important questions that Sabrina explained. These could play a role in finding out how to incorporate engineering into our learning environment. We will find out what can be learned, how to learn it, who has the problem that needs to be solved, why is the problem important to solve? Each activity that we will work through will answer these questions so that you can see how the activity supports these engineering questions. What can children learn? Well, according to Richard and Donahue, 2014, the practice of engineering design reinforces and provides a method for integrating concepts in mathematics and science. Children can learn more than just math and science, but problem solving too. These researchers also point out that standards are changing. Have you seen the next generation science standards? There have been many advances in the world of science and how students are learning science. Why wouldn't we adapt? Although the standards start at kindergarten, the ideas can be geared toward younger learners. I've included the link of the standards on the reference page too. We can include an engineering activity right into our day. Let's check out one. All right, how early for the learning? It is suggested that students as early as 15 to 16-year-olds can start learning engineering education. At this age, a child can be encouraged and motivated to specialize in a field of learning. The idea is that this age, learners can work together and focus in on their communication and presenting skills that will allow them to express their ideas and motivation towards a learning engineer. Young children are able to communicate some of their ideas, but we can help them by teaching them about the scientific terms to enrich their vocabulary. Young children are able to collaborate together to determine how things work and working through simple challenges together. We can create this opportunity for young children and older children alike in your learning environment today. Let's see an example. All right, can you build? This is based on a story that you can see here, Tyrannosaurus Rex. I love incorporating ideas that can be supported by literature. This activity is called Can You Build? Thanks to Deirdre Daniels at jdaniels4moms.com, she has created these engineering building project cards to help support the book. Here is what you need. We need some type of building block, Legos or other block. We need the book, and we need building cards. I read the book and provide the building cards. For this example, we selected the chair and the blocks to inspire and create. Okay, so we're going to take a look at a short video. Here we go.
What is the problem that needs to be solved?
Someone needs a place to sit.
Who has the problem that needs to be solved?
My dolly needs a place to sit.
Why is the problem important to solve?
Because my dolly wants to sit at the TV.
All right, I hope you were able to hear that. My little helper's voice was really low in that video, but basically she said that she was answering all my questions. What is the problem that needs to be solved? She said my dolly needs a place to sit. Who has that problem that needs to be solved? It was her dolly. And then why is the problem important to solve? My dolly needs a place to sit during her tea parties. So we had successfully made a dolly chair, perfect for tea parties. The Legos were great to create this one-of-a-kind chair, perfect for her dollies. All right, so what is the engineering process? It is a multiple-step process that allows engineers to think through different stages of design and trial. Check out this visual. What can we take away from the engineering process? This engineering design process picture was created by Kids STEM Lab. We can have students ask, what is the problem? Imagine, what are the possibilities and solutions? Plan, what will your solution look like? Create, build your plan. Experiment, test your solution. Improve, how can you make it better? Share your results. If you think this visual is exciting, be sure to check out Kids STEM Lab blog. There's lots of good ideas for including engineering activities in your learning environment. All right, so how will children learn? According to Sigmund, 1997, it is explained that Jerome Bruno had a hypothesis that went like this. Not that anything can be taught to a child of any age, but that if is to be taught effectively, if it should be done in an intellectual, honest way. He went on to explain that it is important to plan the best experience we can to provide the learner with opportunities to practice different skills and behaviors. It has been found, according to Sigmund's 1997 research, that when a learner is involved with hands-on approach and is engaged in an activity, learning to solve problems, they will acquire the information. He also created a design belief that targets technology skills that will help the learners be successful later in their educational careers. The skills include, and not limited to, divergent thinking, creativity, critical thinking, decision-making, problem-solving, identification, material selection, working to criteria, and evaluating solutions. He connected all of these ideas to literature and has developed lesson plans that provide the learner with hands-on experience that will enrich their learning and inspire the engineer within. This article was written in 1997, which is evidence that the idea of teaching these engineering skills to preschoolers is not a new idea. But where do we go from here? Let's jump to our next activity. This is from whatsupmoms.com. We are now going to do the cup challenge. Here's what you need. Cups and strips of either cardstock or cardboard. All right, and we're gonna take a look at those 3 questions that my little helper has helped me so you can see what we're gonna build.
What is the problem?
People need a place to work.
Who has the problem?
A company or business.
Why is the problem important?
So the company can be successful.
All right. My second helper was a little more vocal. All right, let's jump back. Okay. I lost my picture. Okay, and here is our successful tower. We used the cups and the cardboard to create a tower to house our company, so our workers had someplace to be. All right, re-engineering. According to Razzo 2014, young learners have the impact to create solutions to the world problems in the future. With this idea in mind, Razzo believes that we need to teach children young so that they can gain the confidence and knowledge and understanding toward concepts and skills to one day be able to analyze ideas and create solutions. It is up to us to provide opportunities for young learners so that they can be familiar with the skills needed to become experienced engineering professionals. He also went on to explain his great determination that educators will provide good opportunities to ensure learners are equipped with knowledge and experience at an early age about the ideas of engineering. According to researchers, Alvarez, Singdon, Alvarez, Perez, 2014, information needed to be collected by the Industrial Development Plan of the Faculty of Engineering from a university in St. Louis. The study included a sample of students and teachers, which evaluated two different teaching techniques, problem-based learning and cooperative learning. Here are the rubrics used to collect a sampling, which I have included so you can get an idea of what they focused on. The results, which would lead to the development of an innovative educational model. The researchers first conducted some teacher training to ensure that everyone had the same background knowledge and understanding of the two models used. The results revealed that both models were helpful in teaching students. However, they thought that they still found benefits in the traditional methods. In conclusion, the researchers will use a mix of different methods and models to create their new educational model for engineering students. We can use this information in our own learning environment. Providing learners with opportunities to learn in different ways can help in learning and strength in the learning process. Maybe it's time to evaluate your own method and mix in a little bit of different models to help you expand on that learning. Integration into the learning environments. How to integrate the engineering into that learning environment. So today's preschoolers are tomorrow's inventors and problem solvers. These authors reviewed research which revealed that the enhancements in methods, STEM specifically, will require well-designed lesson plans to produce opportunities that will allow for learners to explore and investigate ideas. There are 6 main ideas that were discovered through their research to help integrate engineering into the learning environment. So first, both educator and parent needs to appear excited and supportive towards this type of learning. Educators need more training in professional developments. Use communication, science to build public will and understanding. Improve how research is funded and conducted, and building a system of high quality early learning for birth through age 8. And our last one, expand the availability of STEM charging stations such as apps, programs, etc. According to the authors, only then will America's most precious assets, youngest children, grow, bloom in a world where STEM learning is no longer a luxury, but a necessity. Together, we can make STEM successful. All right, so this idea came from playgroundparkbench.com in conjunction with the story 21 Elephants and Still Standing by April Jones Prince. The elephants in the story needed a way to cross the bridge. For this example, we're going to create a bridge for dinosaurs. All right, here's what you need. A book, dinosaurs in our case, items to create a bridge. We have toilet paper tubes and paper towel tubes, cups, and craft sticks. All right, and my little helper is going to help us explain those questions that engineers need to ask themselves.
What is the problem that needs to be solved?
The dinosaurs need to get from one island to the next.
Who has the problem that needs to be solved?
The dinosaurs!
Why is the problem important to solve?
So the dinosaurs can have fun on the other islands.
All right. So we need to get our dinosaurs to the right place. So here, our successful bridge, a bridge for dinosaurs or elephants taking a walk across. So sorry. Oh, I lost you. Hold on. Oh, all right. Gotta get us back on track. So sorry. Okay, there's our dinosaurs. All right, dinosaurs, let's move on. All right, so according to Busceme, Greenfield, and Mayfield in 2018, we need to use children's natural curiosity about the world, providing opportunities to engage children in experiences. These skills that we can foster include and not limited to critical thinking, problem solving, collaboration, persistence, and hands-on learning. Learners need to use these skills to develop predictors and come up with solutions. It is important, according to these authors, that educators offer a theme to capture children's attention and integrate it into our current instruction. Children will also learn from failures, which we will discuss a little later in this presentation. Young learners will learn about taking risks, persistence, tolerance for frustration, sustaining focus, and trial and error. The authors do feel that science and engineering interventions is limited to early childhood education learning environments. It's time to change this, allowing for contextual experiences that make learning more meaningful and captivating for children. According to the study conducted by Malino, Terry, Irving, Lynn, and Edmondson, that surveyed 200 students and 14 teachers, found that the use of integrated STEAM units supported young children understanding of engineering and technology. Just in case you're not familiar, STEAM stands for science, technology, engineering, arts, and mathematics. It was thought that these children might not have the opportunity to learn about these ideas about engineering and technologies at home or in the community. So it is important that we include some exposure to these ideas in a learning setting. These researchers didn't find that one grade level did better on evaluations of learning about engineering and technology, but they did suggest that earlier that children learned about these ideas. The more they learn, the better. The visual is a great one from Kids STEAM Lab. It really shows that A makes a difference on how children learn and see the world. Benefits and barriers. All right, so we're improving the learning. Heffelben, Hama, and Rajum 2012 discussed how problem-based learning has helped in teaching undergraduate engineering education classes. However, it doesn't seem to be the most effective way to teach college students. Project-enhanced learning, however, seems to be able to enhance the engineering courses that were provided. The different approach encompasses open-ended problems and allow abundant opportunities for students to make the decision in the design and assessment of their own work. According to the authors, a faculty member stated that the problem-enhanced learning can provide an immediate application of the theory that they are learning. In engaging the problem-enhanced learning, they explain that providing time for projects and allowing teams to form based on intellectual composition helps greatly. On the chart, you can see the similarities and differences between the two models. The teacher acts more like a facilitator to help promote skills and concepts in the PBL approach, whereas the PEL approach, the teacher's in charge and then promotes the learning skills such as communication, teamwork, research, leadership, etc. Students are making the decisions about the projects they are working on in each approach. The problem-based learning has been used in learning environments to ensure that the learners are gaining insight into finding solutions to problems. Do you think the PEL approach could be used with younger learners as well? It seems to work very well for engineering college students. Not only are they able to find solutions to problems, but also learn some good skills along the way. All right, so if I can build a car. Building a car can be a difficult task. With the right book and good supplies, an engineering can make a car fit for, well, in our case, a little painted peg figure. This book, How to Build a Car, by Krummick and Lacey, shows all the different parts of a car. A child could flip through this to see great pictures of different car parts and how they are put together. For our example, the supplies will be glue, craft sticks, straws, pipe cleaners, and lids. Okay. I have a little volunteer that's going to help us answer our 3 questions, which played before. So we're just gonna, I'll just tell you what was said. So what is the problem that needs to be solved? Neville, our peg figure, needs to get from the castle to the train station. Who has the problem that needs to be solved? Neville. Why is the problem important to solve? Neville needs to get to the train station before the train leaves. And here is our car, a perfect car built for a little painted peg figure. All right. According to Joe Fresh, 2013, we need to be sure that we discuss failure. We spend so much time trying to ensure success and avoiding failure. Regardless how much we try to prevent it, failure is always a possibility. How can we tell children about failure? Well, this author explains that we need to talk about failure and show learners who has failed so that they can see that it can happen to them. Take this picture, for example. The engineering minds had great expectations of the bridge. When finally, in the last stages of completion, they noticed that there is a problem, a major problem that will take time to re-engineer and fix it so it is usable. Take the Millennium Foot Bridge in London. When it first opened, the bridge would sway while people were walking. Engineers had to add dampeners, shock absorbers to the sides to reduce the swaying. Gould, Eckel, Schra, Anderson, and Brahmi in 2015 used observations of 66 preschool children engaged with large, lightweight blocks in more traditional play materials to describe preschoolers' engineering play, a new construction focused on early design and construction related to thinking and behavior. 3 areas were focused on during this learning environment: large block area, dramatic play, and the playground. The results revealed that there was a high frequency of visitors to the large block area. which offered more opportunities to be engaged than the other areas. There was no gender differences found. Here is a picture from the study showing these large, lightweight blocks during play. Students were able to use the blocks to create their own design and structure. Students, both genders, interacted with the blocks, showing creativity and imagination. Groups of children as well as individual children worked with the blocks. We are engineers. According to Raven, Huzi, and Kava, in 2018, children are natural engineers. Children actually have the capabilities of learning while reasoning and inquiring. We need to provide the opportunities to allow a chance for children to engage in science exploration and discovery. We can ask questions, provide models, help design solutions, and develop discussions about the scientific process. Some of the lessons that were suggested include building bridges and towers, which we just did, catapults and boats, the three-dimensional learning, as the authors referred to it, follow the three-dimension learning models to frame the unit. They focused on asking questions, defining problems, developing and using models, planning and carrying out investigations, constructing explorations, and designing solutions. We're on to the future. Linder Emerson, Hofra, Vest, and Econ in 2016 wanted to paint a picture for educators as to why and how we need to change to encourage our learners to be innovators and inventors. Here are some profiles that might help you get you thinking about why and how to incorporate the idea of STEM in your own learning environment at your own level. Here we go. Profile 1. I want to incorporate STEM, but I'm not sure how to do it. You could feel that you don't have time or the resources to prepare to incorporate it into your learning plan. Things to keep in mind. STEM lessons normally incorporate many standards into one lesson, which in the end will save you time. You can use what you have on hand for materials that you can use within the lessons. Finding resources to use to teach from could also be a problem. According to Linder Emerson, Heffron, Beth, and Efkoff, one of the most effective ways to integrate STEM instruction is to think of each lesson as a problem for children to solve. In profile 2, I've been able to do some STEM in my classroom, but I would like to do more. Keep focused on that STEM process. Early childhood STEM lessons should identify how children are problem solving and thinking critically, how they're reasoning and justifying their decision making, and how they're communicating their understanding of the topic. Off to profile 3. STEM is an integral part of my classroom practice, and I look for ways to make it even stronger. Think about incorporating literacy, like we have seen in the activities today. Allow flexibility in your schedule and get learners to collaborate and work together. From No Time for Flashcards, there's an entire list of books to support engineering. One I really enjoy is 11 Experiments That Failed. This is a great book about failure. Failure is one area that we need to consider when working through the engineering process and considering the important questions all engineers ask themselves. Engineering lessons are important to consider. Allowing your young learner to determine what problem needs to be solved, who needs help solving it, and why does the problem need solving will help the learners tap into their inner engineer to take control over the making process to create a final product that can help solve a problem. Add some engineering ideas and concepts to your lesson plans today. And here are all the references that I used to support the engineering process. All right, Miss Shipley.
Hi, everyone. Thank you so much, Dr. Krummick. Do you want to have a question and answer and see if anybody has anything?
Sure.
Okay.